This is the workshop about cookies, and I'm very happy to welcome on board for especially this Mr. DIETER.
I prepared something like that. That's a stamp, and that's the cookie cutter. So each cookie will look like a small module. So that's our plan. I hope it will work. So we have to start with the pastry. I prepared a little bit of butter and sugar and eggs, and now we have to mix it. Mix is very important also in the modular system. It will take a few minutes because everything has to be mixed very good, so that the different ingredients are totally mixed together. We also add a little bit of vanilla. Makes a good cookie taste. And a little bit of lemon. Very good. My applause. Okay, now we stop it and now we add the okay. Oh, I forgot something important. Cinnamon. Cinnamon is always a great taste for Christmas cookies. And after the pastry is ready, we have to do it to store it in the refrigerator for about 1 or 1.5 hours. And now we separate the pastry into 2 approximately equal parts because we want to do 2 different kind of cookies, standard cookies and vintage cookies, because as you may know we also have vintage modules with black panels, and we want to make both of them. Taste is okay. You want to try it? Okay. I think we take everything. Okay. Cookie pastry will go to the refrigerator. So this is no longer for beginners, I'm sorry. So we will go a little bit deeper into the modular. What do we offer since a couple of months? Oh, I forgot a patch. Just a second. Okay. Are polyphonic modules. What is the difference between monophonic modules and polyphonic modules? If you play polyphonic, for example, on a piano, you can play at the same time different sounds. For example, if you play 4 keys, you have, let me say, 4 oscillators, 4 filters, 4 envelope generators, and 4 VCAs. But if you convert this into the modular, you have the problem that you have normally for each VCO and each VCF only one control knob. For example, if we look at the filter has one control for the frequency, for the manual frequency, and one control is for the envelope intensity, which I showed in the first part of the workshop. If you have, for example, a 4-voice polyphonic system, you would need 4 times this filter, and you would have to operate all controls at the same time, because you want, if the filter goes up, it should go up for all 4 voices at the same time. So you would need kind of 4 hands which operate simultaneously as all the knobs. So of course that's not working. So what we see here is a polyphonic filter. It has virtually the same controls available as a normal monophonic filter, which has only one sound, but each of the controls affects 4 filters simultaneously. If I, for example, operate the frequency knob, of all filters the frequency goes up or down. If I operate the frequency modulation knob, that's nothing but the CV knob here on the monophonic filter, the envelope intensity or envelope height for each of the 4 filters is controlled simultaneously. So the polyphonic modules help you to control the parameters of several filters or VCAs or VCOs at the same time with one knob only. So I will show you how it works. Here we have 4-fold VCO. It's one module which has 4 VCOs inside. It's very similar to the single VCO which I showed you in the beginner's workshop, but 4 of the VCOs, of these VCOs behind one front panel. And I have made a patch where the 4 VCOs, the sawtooth output of the 4 VCOs, are connected to the 4 audio inputs of this polyphonic filter. The output of the polyphonic filter goes into a polyphonic VCA, and I have 2 polyphonic envelope generators. One is used to control the 4 filters, and one is controlled the 4 VCAs. After all, it's not different from the basic structure which I told you. It's just 4 times everything, but with one control only. How about the cookies?
All good, all good, don't look.
It's all good. Okay. Hey, look at me. Look at me. Not only to
No
the cookie. Okay. And now I use again the keyboard. Finish this. Okay. What you see here is I have not mentioned this function in the beginner's workshop. It's an interface that derives from the keyboard 4 gate signals and 4 CV signals. This keyboard, which I showed in the beginner's workshop, has only 1 CV and 1 gate output, but it's for a polyphonic application you need several gate and several control voltage at the same time to play polyphonic. And I use now only the MIDI output of this keyboard to control a polyphonic interface that generates the CV and gate voltages for this polyphonic patch. So this has a unisono mode. That's very important because you have to tune the VCOs. VCOs are a little bit temperature dependent, depend a little bit upon humidity and so on. So before you start, it's like an orchestra. Before they start, they have to tune, and it's a similar function. So let's see. Well, this is a unisono mode. That means all 4 VCOs should have the same pitch, or in other words, the MIDI interface generates 4 times the same voltage, and now I have to adjust the pitch of the 4 VCOs so that they are in tune. They are already nearly in tune, but you can hear if I change that one of them, it's a little bit detuned. So before you start, like an orchestra, you have to tune the VCOs that they are in tune. Okay, that's good for the beginning. And now I change the mode into a polyphonic mode. This means if I play 4 different keys, the interface generates 4 different voltages which correspond to 4 different pitches, which is nothing but a chord. They are still a little bit out of tune, but forgive me, it's very complicated to tune it very carefully. But for the demonstration, that should be enough. Now I can play on the keyboard like on a piano or a polyphonic synth. And what I want to show you is now the filter. I have only one control for the frequency of the filter, but it affects all 4 filters at the same time. And the same is for the resonance. It affects the resonance of all 4 filters at the same time. So that's the main difference between the normal monophonic structure of a patch and the polyphonic structure of a patch. I don't want to tell you the details about the polyphonic Adsr. It's just the same as the envelope generator I showed you at the beginning. But you have one control for attack, which affects 4 envelope generators, one control for decay, which affects 4 envelope generators, and so on. So, but the idea of the polyphonic modules is not simply to build a polyphonic synthesizer with a keyboard, which you already know. You can do much more within the modular with these polyphonic modules, and I wanted to show you some examples. For example, it's possible to take the CVs from the keyboard, but the gates, for example, for a trigger sequencer. What do you see here is a trigger sequencer. You can see only the... Kann man den ein bisschen drehen, dass man den komplett sieht? Difficult? Okay. Here you see a trigger sequencer. That's also a sequencer which is similar to the one I showed you the beginner's workshop, but it generates only triggers. No control voltages. It works just like a drum machine, but it does not generate sounds, but only triggers. You have 8 rows, which generate up to 8 triggers, and you can set or reset each trigger on each step. If you know the TR-808, it's a very famous drum machine. It's the same working principle. What I now do is I take the gates, not from the keyboard, not from like play, but I take it from the sequencer, and that sounds like that. I can still play on the keyboard and take the control voltages for the pitch from the keyboard. But I take the triggers from the trigger sequencer. That's one of many examples what you can do. I have at home also a random structure, but I don't have it here, where I have a random voltage, which is one after the other connected to the CV inputs of the VCOs. That way you obtain random polyphonic chord structures. So it's totally without playing anything, it generates polyphonic chord structure. That's just an example. And I wanted to show you something other which many people don't know, and to speak the truth, I didn't know it myself before I visited another workshop from a band in Munich, Ströme. They are friends of mine, and they told me a trick which is very simple. And this is, you control a normal synthesizer voice, like the one which I showed you in the beginner's workshop, with two different envelope generators. And you trigger the envelope generators in a different way. This obtains a very, how should I say, a musical sound. I will show it to you. I have, I use the same modules which I used for the basic stuff, but now I have two different envelope generators which are used to control the filter and the VCA. And what I do is that the two envelope generators are triggered in a different way. One envelope generator is triggered permanently with the clock of the sequencer. That means each advance to the next step of the sequence generates a clock. It's a permanent running clock, and it generates a permanent running envelope. And the second envelope is controlled by another trigger row where I can set and reset each step individually. And this, with this, one obtains very, very good sounding sounds. Let me see. What you hear now is a sequence which is generated by the 8 knobs of the sequencer. And it's permanently triggered with the clock of the sequencer. At each step of the sequence, you hear the sound because the envelope is triggered. And then I have another envelope. I should mention that two envelopes are connected to a mixer. That means I can mix the two envelopes with two controls of the mixer, and the output of the mixer goes to the filter. So this is the envelope you heard already. And now I have another envelope which comes only on several steps, not on each step. And you can mix both envelopes to obtain very living sounds. Sometimes for me it sounds if it would be not only one voice, but two. Oh, are you ready? Okay, that's a trick which told me my friends of Ströme, and I wanted to show you something I use also very often. That's a sound sampler, but I don't use it in the usual way as a sampler. That means I do not simply record a sound and play it back. That's too easy for me. I use it in we call it wave shaping mode. That means the sound is cut into many little pieces, and each piece of the sound is output in a small loop. And with a control voltage, you can define the position of the loop. It's not that easy to understand. It's like if you take a tape from a tape recorder and cut it into little pieces and play back always small pieces of this tape. And I wanted to show you what one can do with such stuff. So let's see. I have to make a patch. At first we hear the pure output of the where is it? It is here, of the sampler. Okay, I just go directly from the output of the sampler to the mixer. So let's see.
Ich bin der Musikant mit Taschenrechner in der
Maybe
Hand.
some of you know it. It's nothing but from Kraftwerk.
Ich bin der Musikant mit Taschenrechner in der Hand.
Now you have the possibility to change the pitch.
Ich bin der Musikant mit Taschenrechner in der Hand. Ich bin der Musikant mit Taschenrechner in der Hand.
Well, that's how the sampler works in the normal way. But what we do now is we change to the wavetable mode where this small loop is repeated, and then it sounds like that. Just a moment. No, that's not what I wanted to show you. So, okay, that's. Now you have a voltage where you can go through the sample forward and backward like that. It's not perfect because the loop length does not correspond to the pitch of the sound, but you can see how you can go through the. And you can change the pitch. Or the tief or lower. Okay, but now we'll show you what I do with that. I control the position of this loop with the lower row of the sequencer. That means the CV output of the lower row is used to address the position of the loop. And now you have to play around a little bit with the position and the width, and you obtain very interesting sounds. But that's a little bit too raw for my ear, so I use also a filter to process the signal and a VCA. So let's see, it should be this one. So, and I trigger it from one of the triggers. So that's the sample running through a filter with envelope generator and a VCA. It's a nice bass drum or something like that. Okay, and what I will always use in my small performance, I hope it will work, is a little bit working with noise. I have a so-called digital noise generator. Digital noise generator is not that easy to understand. An analog noise generator is nothing but amplification of an electronic noise that already exists. A digital noise is working a little bit different. It's so-called shift registers, which are fed back to the input, and this also generates kind of noise sound. So let's see. First of all, we hear again the pure noise sound. That's the pure noise sound. And because it's a digital noise sound, you can change the rate of the shift register. Shift register is a difficult word. And if you change the rate, you change the sound of the noise. Now I reduce the clock, and if I go down and down and down, it's like a random clock or something like that, or Geiger counter, or I don't know, something like that. And if you go up again with the frequency, you obtain normal noise sound. And I have a voltage controlled resonance filter, A127, which I use to process the digital noise. Okay, here it is. And this sounds like that. I have 3 bandpass filters, and each bandpass filter has its own LFO that is used to modulate the frequency. You can adjust the frequency of each LFO, the level of the modulation, the frequency of the filter, the resonance, and the level, and that way you obtain nice sounding noise. If you increase, for example, the frequency of the LFOs, it's like that. But I prefer the lower frequencies because I will show you, I want to use it with lower changing sounds. And what I now do is I process this again with a VCA. So let's see, that should be audio in of that one, okay. No, the mix goes in there. The output, okay, you should connect the output, otherwise it doesn't work. Okay, now we have again the same signal, but I have added now a VCA with which can be used to adjust the level. And if I use envelope generator to control the VCA, one obtains sounds like that. I take one row of the trigger sequencer to control the envelope generator, and the envelope generator is used to control the VCA, so it's kind of percussion. Yeah, these are the elements I want to use in the small performance of okay, maybe we can have some cookies. So before I do it, so if the performance is not that good, hopefully the cookies will be totally important. Because I have a new module designed a few weeks ago, which has nothing to do with sound. It's just light. So you can see here LED stripes glued to the case. And these are RGB LEDs. That means each LED consists of a red, blue, and green LED. And you have individual controls for the colors. And this is the controlling modules you see. The first 3 knobs are used to adjust the basic brightness of each color. So this one is the blue. This one is the red. And this one, yeah, it's for Chris, is the green one. And of course, we have control voltage inputs. So we can use, for example, envelope generators, the envelope generators of your bass drum or whatever you want to control each color individually. So let me see. We can use I can take. Let me see which is this envelope. No, this one. This one. I need a multiple, external multiple, and I use the same. That's the envelope of the sound, and this I use, for example, to control, I don't know, the green. No, it's not working. Why? Ah, here. And you can take, for example, the envelope of, I don't know, of this one. I need more multiples. I don't know. Yeah. Let's take this for the red one. So you see how the colors change. You have to look it. You'd have to see it here. It looks much better than in the video. Okay, that's wanted to show you that I don't forget it. So, but now up to the cookies.